Hello everyone, good morning. In today's session we shall design a temple at Paladi. It is a ground and first story building with floor height of 11 foot. This is the floor plan. Let us first understand what is given in the floor plan. These are the columns, the red ones and the blue ones. The green ones and the dark blue ones are the beams. So first of all, to model it, we have to start a new model. Let us first start a new model in STAAD.Pro. So this is the first window that you see when you open the STAAD.Pro. Just click on new project. It will be a space project. Name shall be temple at Paladi and the location shall be at the desktop. It shall be temple at Paladi. So you have to select the units of the model. We will be working in SI units, that is meter and kilonewton. Click next. It is asking me to add beams, plates, or going to structure wizard or edit job info. I'll be selecting edit job info so that nothing else comes. In the job we can write temple at Paladi. Client is XYZ. Job number, you can write down everything that you want to do here, and I just do this thing because I can understand and also I can get the idea when it did made. Okay, so our first task shall be to get the dimensions of the columns so that we can model the columns first. So in order to get the dimension, you have to select the center to center of dimension. As you can see, when we are measuring the dimension, it is giving us in feet inch. So you have to go to this small arrow at the end of the dimension tab, open the dimension style manager, click on modify, go to alternate units and press display alternate units so that you can see the alternate units below the footage units. And now when we measure center to center dimension, it is showing us that it is 4115 mm in horizontal x direction and 219, almost 300 mm in z direction. So let us first give dimensions to all the columns, and this is the last one. So these are the dimensions of column center to center. In this whole video we shall be modeling, analyzing and designing the structure. It will be a longer video, probably the longest video of my channel till date. I hope you will enjoy the same. And yeah, my English is a little bit weak, so kindly bear with me. I'm just giving the center to center dimensions of all the columns. Okay, let's just select the centers. It is giving, when I put my cursor here over the edge, it's showing me the center. So I'm selecting that center, and if I know that the dimensions are continue, I can just write DCO, that is dim continue, and I can just select the next centers so that it can give us the dimensions. I'll be needing one Z dimension here too, and okay, so we have the X and Z directions. Let us just take this one too. I'm taking center of these two beams to give the dimension. Okay, so let me show you in half so that you can understand. Now I have the dimensions of the nodes, that is columns, and I have to give it to the STAAD. I'm selecting the geometry tab. It's showing me the grids. I'm just closing the snap node beams, and this is the node table that we can use to input the nodes. So first node will always be 0 0 0. STAAD.Pro works in XZ direction plan, so that we are putting 0 0 at the XZ0 node location, and whole our building shall be in the fourth quadrant. So our top point shall be this one only. Okay, Now the second node, where it will be horizontally 4.1511 and vertically 3.3, sorry. In x it will be 0.115 and z it will be point, sorry, no, in y it's 0, in z it's 0.3. So this is the second. I'm clicking on display and drawing the top view so that I can understand how tapered it is. Okay, so this is how you can add the nodes using the table. Now when I know I only have to give the node in x direction 2 nodes, so I can use translation repeat for that. Just clicking on the node cursor, selecting the node, going on to translation repeat. The same command you can get from geometry and translation repeat. I want to create 2 nodes in x direction, so my global direction shall be x, my number of steps shall be 2. This is the generalized default distance. I can change the same from here. The first step shall be 3.268, that is 3.268. The second step shall be 3.276. I can link the steps so that a line can be drawn. I can renumber the bay to the starting from the node I want. I can copy all the parameters or geometry only. In this case these are only nodes, so whatever the selection might be, it will not gonna affect the model. I am pressing OK. As you can see, 2 nodes has been created. Now I have to create 2 nodes in the z direction. At location, I'm just first copy pasting it, the last one, this red one. I'm modeling this C6, so I'm selecting the fourth node, that is C4 node, and I'm just pressing Ctrl C, Ctrl V. It will be showing me the copy paste window. For pasting the window, you can select 2 nodes for getting the distance, or you can give the dimension in xyz direction to how much distance you want to go. So we want to go in z direction, and the distance is 3.476. Let us say 3.477, and I'm pressing OK. The C6 node has been created. Now in x direction, the C5 node is at 9.253. So I'm just selecting it, I'm copying it, pasting it to x. As I am going to in the left direction, I'll have to put minus direction, 9.253 in minus x. As you can see, the node has been created. Now I can copy it, no, because this is 9.253, this is 9.763. It is almost a difference of 510 mm. So I'm just selecting the C6 node, copying it, pasting it to the z direction, that is 3.625. Okay, I'm just copying it again, pasting it to x direction, minus 9.763. Okay, now I have to create 4 more columns, that is C9, 10, 11, 12. I'm just selecting the C8 node, copying it, pasting to z direction, 3.28, 4.328. Now I have 3 distances, and I can use translation repeat for that. I'm going in the x direction. I have to draw 3 nodes. The first node shall be at minus 4.915. Just correlate the distances from here, AutoCAD, so that you can understand how the distances are being played. The second node shall be 1.598. The third node shall be 3.920. I have given distances in minus direction, as you can see, because I am going leftwards. I'm pressing OK. I've got the 4 direction nodes, but the C9 and 10 nodes needs to be shifted towards negative Z by the distance of 623. So I'm selecting both the nodes. I'm pressing F2. That will open the move window, or I can go to geometry and press move and joints. The same window will open. Okay, I have to go in z direction to the extent minus 0.605. 0.623. Retain connection means if you have drawn beams and other entities and you are moving the nodes, other entities shall be stretched out to that node. Not just the node, all the entities that are connected to that nodes will be shifted. Okay, so I'm just pressing OK, and the column nodes has been completed. So now we have to do, all we have to do is we have to draw the lines or say members, instead let's say beam, to complete the floor. Or I can do one more thing, I can, let us say, draw the columns first and then create the beams. To generate the columns, I'm selecting all the nodes by pressing Ctrl A. I'm again going to translation repeat. This time it will be in the Y direction. There will be 3 steps. Let means plinth level, ground floor slab, and first floor slab. So I will have to go for 3 steps. Let us say plinth level is at, it will be a structure with pile, so plinth level shall be at just 300 mm down the ground level, and pile top level, and plinth level shall be at 750 from the ground level. So our distance shall be 750 plus 300, that is 1.05 will be first step. And then it is 11 feet. 11 feet in meter shall be 11 into 3.281, sorry, 11 into 0.3048, it will be 3.35 meter. So we are linking the steps this time because we want to create the beam columns lines, column lines. So that I am pressing OK. As you can see, the column has been created. Now I have to draw beams. I'm doing the front view. I'm selecting all the nodes at plinth level. I'm pressing Alt V and V again. It will be selecting this option, view selected objects only. So as you can see, the plinth level nodes has been selected and the view has been created for that nodes only. Now I have to draw the beams. I can select the add beams from here, keep on pressing it, it will open the options of that command. I am selecting node to node beams. You can go to this option from geometry, add beam, and add beam from point to point. The same option will open. I have to just draw the beams by selecting first point, selecting the second point. I am creating left click, drag it, left click again to the another node. It will create the beams. Now these lines are purely in the X direction. I can select the whole lines nodes. I can go to geometry. I can connect beams along X axis. It will be creating the beams in X direction in the faster way. As you can see, the Z of these nodes are same. I can go to geometry. I can go to connect beams along Z axis. 3 beams has been created. This is how you can create the beams by different methods. Now you have to create a beam here and then join here. Let us first copy this beam and paste it to the second column, okay, and third column. So as you can see here, I have got this thing. I can create a beam at this point. I can just copy it, or say I can control X it and control V it. Now I am selecting the reference point. It is showing me the beam with a blue tick. This will be the reference point at which I am just taking that beam. Clicking on that node will get the distance from the first point, the reference point, to the point that I am moving to. Pressing OK will shift the beams, we can say, to that point. Now all I have to do is I have to create a vertical beam. I will be going to geometry, add beam by perpendicular intersection. So this, first you have to select this beam node and then the beam to which you have to draw a perpendicular beam. Now this is a residual beam that I don't want. As you can see, when I'm selecting it, it will be showing me the beams table. The beam number is 59. It connects 56 and 55 node. Node A means the first node, node B means the second node. As I have selected it, it will be highlighted. I am just pressing delete to delete that beam, and the beam has been deleted. The same way I have to draw this beam again, because this is not coming in the perpendicular direction, as both the column centers are a bit different, we can say. Ideally it should not have been like that way. We have two options for that. We can shift the column towards left to that beam, or we can just put the beam at the junction at where it is coming. So first let us select these two beams, go to geometry and intersect the beams, so that you can get the intersection point where these beams are being connected. As you can see, it's a very small distance. Selecting it, it will be show it is just 31 mm. The ideal condition I'm doing is I'm just shifting my column to that point. So how I will do it, just see, I have selected all the columns. I am scrolling up in the mouse so that I can zoom it to the extent that we can see both the nodes. I am just copying it and pasting it with a reference point of the node that I can be referencing to, and pasting it. It has created the new beam, new column. My old column has already been selected. I'm just deleting it. It will be asking me to delete 3 beams. I'm saying okay. Just remove the nodes that are abandoned now. Pressing OK. Now all I have to do is I have to join these two beams so that the whole beam becomes one. Right? So I'm selecting these two beams, 1 and 2. I'm going to geometry node, geometry menu. I'm selecting merge selected beams. It's showing me that these two beams will be joined with the properties of 58 number beam. I'm pressing merge. As you can see, the whole beam has been merged to one. I'm creating the whole view, creating the front view, selecting the points or say nodes and beams of plinth level, going to view and view selected objects only. As you can see, almost most of the beams has been created. Only the left one vertical beam is pending. Let us create that one too. Node to node, node to node. Now we have to create this one, right? So as you can see, this beam is 1.584 towards left. I'm selecting this node. I'll be going to translation repeat in x direction one step, and distance shall be minus 1.585. I'll be linking the step to create the beams. As you can see, the beam has been created from the node. Now vertically the beam shall be of 2413. I'll be doing the same thing, translation repeat, selecting the nodes, selecting the translation repeat in z direction one step, minus 2.1414. I'll be linking the step. Now I have two nodes. I'll be just selecting these two nodes to create the last beam. As you can see, the beams and columns at plinth level has been completed. I'm displaying the whole structure so that you can understand how the whole structure sees. Now I have to copy this same grid to ground floor slab and first floor slab. So selecting the front view, selecting the beams, displaying the whole structure. As you can see, the highlighted beams have been darked. Now just copy it, paste it. Ctrl C, Ctrl V. Select the reference point that you can be selecting for referencing. press OK. Press Ctrl so that you can paste it multiple times. I'm referencing it to this point and this point. As you can see, both level beams has been created. As you can see, the whole structure has been created by this way. Now the next step is to provide the supports to the structure. Go to General tab, go to Support tab, and this whole structure supports window opens. You have to create a support for that. For pile foundation, we will be selecting fixed support. Pressing add will create the support as 2. I'll be selecting front view so that I can see all the nodes at the bottom. The selection is same as AutoCAD. We can select it by window. You can change the selection mode by drag box, drag line or region. By selecting drag lines, it will just select the by lines. As you can see, it will selecting by lines. I've never used it, so I'm not the right person to give the idea about that. The next step is selecting by regions. You can draw the region the way you want. Then press enter or say space. I don't know what to do now to complete the command. And put it again. No idea how to use that command also. Just remove that selection modes. Just select selection drag box. Okay. I think drag box and region will work. No, both are not working together. I'm just selecting the region. I'm selecting the node cursor. Why it's not happening it? Window selection is not working. Why? Let's first do the front view. Window selection has been stopped. Select selection mode drag box. Dragging is not happening. I think I'll have to restart it. Let us pause for some time. So as you can see, we want to select the supports at the nodes. We have to select the nodes where we want to give the support. We should be selecting the support first, because when you are selecting the supports, the selection window that you have selected in the display will be removed. So select the support first, select the nodes that you want to give support to, and select assign to selected nodes in the assignment method and press assign. It will be asking that you are assigning this thing. Press yes. As you can see, the support has been created. Now let us give the properties to the beams and columns that we have created. I am just opening the selection menu, beams parallel to Y. I have selected all the columns by this way. I am showing you again. Just from the select menu, select beams parallel to Y. The same way we can select the beams also parallel to X, parallel to Z. As you can see, the beams which are not in perpendicular or pure X and Z direction will not be selected by this way. So there is an option for that. First select the beams parallel to Y, then go to again selection menu and press by inverse beam selection. All the beams will be selected this way. Now let us give the properties to column. So we are selecting beams parallel to Y. Alter VV will show the display selected objects only. I am going to top view so that I can understand what the column property is being given. Now first we have to define the properties. So go to geometry tab, property sub tab. The property window will open and we will define the property. The first column, let us say this one. All these colored columns are of same size. Let us see how much it is. 475 and 230, right? You can do it by opening the dim linear, selecting cross, so that you can get both dimensions in one single measurement, or else you can do distance, use distance command and select opposite corners. It will show you in the bottom window the size of the columns, that is 9 inches by 1.5 feet. So the size in is 230 by 450, we can say. We are not giving 457 kind of thing, we are just giving 450. The ZD shall be, yeah, in STAAD.Pro, if your column is horizontal, you will be giving horizontal dimensions. If your column is vertical, you will be giving vertical direction dimension for property. We are not going to give the beta angle to RCC members. So I am defining column first. There are horizontal as well as vertical columns of 230 by 450. So we are first giving 450 by 230. 450 is YD, 230 is ZD. The first one is X direction and the second one is of Z direction. The other column shall be 230 by 450, and the red ones are 600 by 450 by 600. So we are giving 450 by 600 and pressing add. You can change the material from here. In our case it is concrete only, so we are not changing it. As you can see, there are both two types of columns only. Now select all the horizontally aligned columns to give the 450 by 230 property. I am just window selecting the columns. These three ones and these three ones are horizontally aligned 230 by 450 columns. I am showing the whole structure. I am creating the whole view, so isometric view, so that you can understand how the columns has been selected. I have pressed top view, so that top view of all the lines has been shown. I am selecting columns by window and pressing control, keep pressing control, so that the old selection does not remove. If I select this and then this, it will remove the old selection. But if I had pressed the control while selecting the new window, it will keep on adding the members selection to the selection. So we have to give 450 by 230 to these columns. It will be asking me whether I want to give or not. As you can see, the property reference 1 has been given to the columns. If I press Ctrl 2, it will show me the solid view of the same. If I press Ctrl 1, it will be showing me the hollow view. Ctrl 2 will give me the solid view. So I am just starting the isometric view so that we can see in the plan how the alignment of the column has been given. Now to vertical, keep pressing control so that the new selection has been added to the earlier one. Now it's showing me the highlight assigned geometry. If this option is check marked, when I will select the reference 2, it will remove the selection. If it is not highlighted, it will not remove the selection. Remember that. It is good to check mark this when you are using this window as to see what is given to which members. But while giving or assigning the members, it is better to uncheck the same. I'm selecting these two columns. I'm just assigning it to them. I can use cursor also to assign. Let us do the isometric view. Press anywhere in the display window so that the selection has been removed. I am selecting use cursor to assign. I am selecting the columns that I want to assign. I am pressing assign. It shows me the I-beam. That means the assignment window has been started. I am just pressing up arrow to rotate the isometric view. I am selecting this arrow to this and it will assign the member. As you can see, I can assign. I'm just pressing escape to come out of that command. I can assign this column to this by the beam numbers. I have pressed shift B to see the beam numbers. By the numbers of it, I'm selecting the property. I am knowing the number. I have started the numbers by pressing shift B. If you press shift B to the display window, it will show you the beam numbers. I am selecting assign to edit list. The list has been already created by the already assigned the members. I am just adding new numbers 8, 20 and 32. I'll press assign. It will be assigning the members to the edited list. I'm selecting the beam columns and it will open, it will start assign to selected beams, and I press assign. It will add the beam numbers to this window. As you can see, this way we have given the properties to columns. Now let us give the properties to beams. All the beams shall be of 230 by 450, right? So the depth shall be 450 and width shall be 230. I'll directly press assign because I have already selected the beams and then defined the property. Now as you can see, there are two columns, there are two beams which are larger because it's a very long span of 9 to 10 meter. So I'll have to change the property of those beams, and at the plinth level I can say that I can get rid of these beams because these beams are too large to construct as well as not needed for the structure. I can make the columns a little bit heavier because it will be a long column in the other directions where tie beam has not been casted. So I'm just removing these beams from plinth level, pressing delete and pressing OK. It will remove the columns from the plinth level. My column shall be heavy in that direction at the because now in that direction the column length shall be this much. Okay, so let us change the property of ground floor and first floor window. I have done front view. I am window selecting. I am pressing shift X to get rid of the properties being seen. I am pressing cross window to select the beams, cross window to select the beams. If the cross window is too large to get the more than half of columns, it will select the columns too. So make it as short as possible to select the beams. I am pressing Alt V to show you the view selected objects only. Now I have to give higher size to this too. As you can see, I have created top view and selecting these beams. If you can see in isometric, both level beams has been selected. This way you can select the beams in multiple levels if the same are in single line. I have to give another size to this for 10 meter, that is almost 30 feet. Minimum 30 inch beam will be required. Let us give the property as 300 by 900 for first cut. It will be 0.9 by 0.3. I am directly assigning because I have selected the windows beams, and as you can see the beam has been heavy down. Now the whole structure property has been given. I am pressing shift X to get rid of this property size that is being shown. You can get all the shortcuts from tinytopic.in. Now let us see how the structure has been created. I am pressing Ctrl 4 to see the rendered view. As you can see, when I have given the higher property, it goes up because STAAD.Pro works on center to center modeling. All the nodes being joined are joined at the center, if you can see. Now you will be asking me to offset the beams so that the beam can be actually be modeled to the point that it should be. As you can see, I have created these two columns in one line, but as you can see, the centers of these beams are 115 mm apart. This causes the eccentricity and eccentrical moments that you should be capturing, but being a slab beam column frame, the effect of that eccentricity will be minor to the extent of almost, I am not sure, but to the extent of 5% only. So we can ignore it. This is not a caudal line that we can ignore it. You should be doing the offset modeling, but in our case we are not doing it. So now that you have assigned the supports, assigned the properties, we have to give the releases. Release is being given to the structure. I am pressing Ctrl 0 to the top view of the whole structure so that I can get the top view seen. I am pressing Shift B to remove the beam numbers and I am going to General tab, Specification tab. Releases are being given to the beams to release the moment at that node. Why you need to release that moment? Because it is a beam to beam connection, and not releasing the moment will cause the torsion to the next beam. So it is better to release the beam to remove the torsion from that end, we can say. As you can see, this beam will support on this beam, so the moment needs to be released at this point. If I'm putting my cursor on it, it will be showing me the beam number and start and end node. As you can see, it's green and blue. Green is the start node, blue is the end node. If I'm selecting it, or say if I press Shift E, it will be showing me the start and end of each and every beam. Let us first standardize the start and end to X and Z minus direction. So I'm selecting all the beams parallel to X. I'm going to tools and I will click on redefine incidence. I'll be selecting second option as my structure is on the fourth quadrant to make all the X direction start point towards left. And now I'm selecting beams parallel to Z, going to tools, redefine incidences, and I'm selecting third option. As you can see, all the starts of vertical beams has been shifted towards down. This will be creating a uniformity of model, as well as it will give you better understanding of the results that you are getting, because if both beams start are at junction, the result will show the start node first and you will be confused with the results. Now let us release this beam to this point at start node. To this is the specification window. When you select this specification, this will open. In beams we are creating a specification that the start node needs to be released in MY and MZ direction. As I have selected the beams, I can directly press assign to assign that specification. As you can see, a blue circle has been created which shows that it is being released. Same way, this beam will be released at end. Click MYMZ, press assign. Rest of the beams are continuous and ending at column, so we need not to give release to any of them. This way the structure, the property, the specification can be given. Now is the time to give the loads to the structure. But before that, let us create groups of slabs so that you can give the floor load easily. To do that, I am pressing front view. I am selecting the top terrace level floor. If you can select isometric view, it will be showing that the terrace level beam floor grid has been selected. I am pressing Ctrl G to open the define group window or I can go to tools. Sorry, I'm just remembering the shortcut, so I'll have to find that command in where it is. Where is group? If you can see, do you see group anywhere? Just comment down in the window, comment window, that it is coming in this tools. It should be in the tools, I guess. Yes, it is in the tools. Control G, create new group. Now the group shall be of terrace level, and the selection type shall be of floor. The group shall be of floor kind. It can be of node groups, beam groups, geometry group, and floor group. We are selecting floor for this. We will be understanding each and every one at the later stage. The terrace floor group has been created, but floor is unassigned. I am selecting assignment method to assign to selected geometry because I have selected the beams and I am associating that beams, selected beams, to this group. As you can see, terrace floor has been assigned. I am saving the model so that we can get the same if any unholy happens. I am selecting front view and selecting the GF slab level. I am creating another group. Now the name shall be GF slab. The type shall be floor. Press OK. The beams has been selected, so I can just press associate. If you want to see which group has been assigned to which floor, you can highlight the same, right? Okay. Now you want to select the terrace level beams, you can directly go to select by group name and select the terrace, select the GF level. Okay, this way you can use groups to assign loads, better selection and better result view option, we can say, because in result option also it will be showing by groups. Let us give the loads to the structure. I'm just making state the whole window because now we don't really need that AutoCAD file as the model has been created. I'm going to load a definition and we will be defining the loads. The first and foremost definition shall be of seismic. I'm sitting at Gandhinagar, so I'll be giving, sorry, not me, the structure will be constructed at Paladi, Ahmedabad. So the code shall be of Indian IS 1893. It shows me all the things, parameters of IS 1893 to give to this structure. The zone will be zone 3, that is 0.16. Response reduction factor, it is an SRMRF structure, that is response reduction factor shall be 5. Importance is 1 only. Being a temple it can be 1.5, but I'm just giving 1 right now. Rock and soil profile, it is on the pile, so the soil is very weak, so it will be 3. Structure type is concrete, it will be taken by default. Damping ratio shall be 5% only. I'll have to calculate Px and Pz. I can use calculator directly from here, I guess. If it is here, can you see any calculator here? I think yes, this is the calculator that we can use, the default STAAD.Pro calculator. I have to calculate Px and Pz. For that I'll have to get the distance, height, x direction and z direction. I can do it from this display node to node distance. Where this command comes from, tools and display node to node distance. So I am selecting this line first. This is the horizontal distance, this is the vertical distance, and this is the height. For x direction time period, the structure shall be with infill walls, so we will be using the 1893 formula of 0.09 h by root d. It is 0.09 or 0.9. Let us check that in 1893 itself. As you can see in 1893, it is 0.09 h by root d. 1893 2016 has been released, but as we are using STAAD.Pro V8i currently for modeling and designing, the same shall not be incorporated in the current software. You can use all the commands that we are showing here to the Connect edition also. Just close this down. So the formula shall be 0.09 h by root d. So first let us just calculate root of 10.663, right? So where it will be seeing the insufficient argument. Okay, no integer engineering calculator root, where to get the root? Okay, so we can get the root by just typing 10.663 raised to 0.5 will give us the root, right? And we can see the result to the normal extent. It will be 3.26. Now 0.0, remove this whole. 0.09 into height is 7.75 divided by 3.26, right? It was 3.26, right? Let us do it again so that we can understand, we can get the right value. 10.663 raised to 0.5 will give us the root. It is 3.26. okay, we can copy this result. We can remove this 0.09 into h, that is 7.5 divided by control V, paste, and exercise. It will giving us the time period in x direction, that is 0.21. and let us get the dimension pz, that is 11.43 raised to 0.5 will give us the value 3.38. Now 0.09 into h, that is 7.75 divided by the result and exercise, it will give us the time period to 0.21. Depth of foundation. If your depth of foundation is below the structure, you have to give this, you have to give the ground level to the structure. If the node same has been given, you can either give any one of them, or you can avoid that, or say you can if you don't give that, the support location will be selected as the depth of foundation. Now all the other factors need not to be given at this point. I'm just adding this definition. Now it is asking me to add the loads. I'll have to give the seismic loads or say seismic mass to the structure, but let us not give it right now. Let us first give the loads. I'm removing this node to node dimensions by pressing this button. Now let us create reference loads for dead, live, and other things. You can select reference load definition, press add, and it will be asking you to give the definition of the load that you are being adding. First one will be dead, that will be self weight, or say DL. You are adding it, then you are adding wall load, then you are adding floor finish. This whole load shall be of dead kind. Now there will be live loads. Three types of live load will be there. One kind of will be live load greater than 3, the other shall be live load less than 3, and the other will be live load on terrace. Now in dead load, when I press add, it will be opening a load application window, As you can see, it is asking me to add load. You can add self weight, nodal loads, member loads, floor loads, etc. The first and foremost load will be self weight in the y direction and -1. To assign the same, if it is not assigned, it will show the question mark at the front. When select it, assign to view will assign the whole load to the whole structure, and the question mark gone. The dead load, self-weight load has been assigned to the structure. Now let us add the floor load. For the self-weight of slabs, because we are not modeling the slabs, we have to give the load of slabs as an external load. We will be giving the loads to group, and the floor load will be, let us say, the structural slab shall be of 125 mm. So the self-weight shall be tools calculator 0.125 into density, that is 3.125. The structural load shall be 3.125. In global minus direction, y direction, the load shall be minus because it is a gravity load. If you want it to disperse in one way, you can do that. If your slab is inclined, you can select inclined floor. In our case, both the case is not assigning, not in the picture, so we are not adding any of them. We are adding self-weight of terrace as well as GF slab the same. Now the second load shall be floor finish. We will be adding floor finish of 75 mm, 0.075 into density of 20. It will be 1.5. In terrace, extra waterproofing will be done to the extent of 1 kN per meter square. So we will be adding floor load to the terrace group to the extent of 2.5, and in the GF slab it will be minus 1.5 for 75 mm finishing. As you can see, when I select the load, the assigned load shall be seen as blue and the other load shall be seen as green. I'm going on clicking on the display window and pressing shift Y will remove the hedged portion. Hedged portion is being to show how tributary the load has been transferred. If I press shift F, it will remove the vertical triangles, the loads that has been assigned. If I press shift V, it will show me the tributated transferred loads to the beams values. As you can see, the loads has been transferred by tributary area method. For more details on tributary area method, you have to Google it. This is how you are given dead load and floor finish. Now let us give the live load. At the GF slab, the live load will be of the extent of 5. Because it is a temple, the gathering can be done. And at the terrace also, it should be given 1.5, but close this because you have to give the terrace load in the terrace reference load case. Go to LLT, go to floor, go to group, minus 1.5. You should be giving it to the extent of 3 because being a temple, there can be chances that people gather there too. So we are giving it to -3. As you can see, the load has been assigned. As the loads are in different load cases, the only load that is being assigned in that case being seen. Now the most important load, that is wall load. Let us just select the first beams, select the specifications and select the support so that we can know where the columns are. I have pressed Alt VV to select show the selected beams only at the periphery. What shall be the height? 3.35, 11 feet. But I guess the beams I have modeled at plinth level should actually be at the pile top level. Yeah, it shall be at the pile top level, right? So I'll have to revise the model. All I have to do is I have to delete these nodes I have to select these nodes, press F2 and heighten the columns by 1.05 meter. I am retaining connections to stick the nodes to the columns, and as you can see the height shall be 4.4 meter. I have to give the supports to the columns. I am just selecting nodes where the columns are coming. Okay, and I am pressing supports, but when I select this the selection will be removed, so I am just pressing Alt VV again to show the nodes only that are columns. Now I can select this, I can assign it to the view, and the columns support has been created. As you can see here there is no column, but support has been assigned. So to remove the support we have to select no support, select the node and press assign. All the other columns are okay. Yeah, is there any column missing? Yeah, this one is missing. Select it, select the support first, select the node then and press assign. 1 2 3 4 5 6 7 8 9 10 11 12 12 columns are there, right? So okay, now we have to give the load to the beams at pile cap top level. So to give the load you have to go to definitions and wall load case reference, and you have to give the member load. As the total height is 4.4 meter and your top beam shall be of 450, the load on the wall, load of wall shall be 4.4 minus 0.45, that is of 3.95 height, and let us say 0.23 plus plaster of 0.012 at the outer edge, 0.006 at the inner edge will give you 248 mm of thickness, total thickness of the wall. Let us say 0.25 to 50 mm thick. The density of all the masonry wall shall be 20 and the load shall be 5 kilonewton per meter height, and your height is 4.4 minus 0.45, that is 3.95, and the load shall be 19.75. we have to give the load of 19.75 in the minus direction because it is a gravity load in the global y direction, and press add. The question mark being seen, we have to select the beams where this load will come and press assign to selected beams. To assign the same, press isometric view so that you can see the load has been assigned properly. Now at the GF slab level the same load at the periphery will come. The inside area is the full hall, so we have to select the periphery only, right? Once this periphery has been selected you have to create the load. Now the height is 3.35 minus 0.45, that is 2.9 to, so 2.9 into 5, we have calculated it earlier, remember that. It will be 14.5. Go to member load, uniform force minus 14.5 and press add, close, select, assign to selected beams and assign. It is this much easy. Same way you have to give the parapet load to the top. I am assuming parapet to be of 1 meter height, so I will be giving 5 kilonewton per meter to the parapet, right? Member load minus 5, add as, select, assign to selected beams and assigned. The reference loads has been created. Now you have to give the seismic mass. Select the seismic definition that you have created, click on add, and you can add the reference load here. You can add everything, but all the dead load shall be coming with 1 factor. Live load greater than 5 shall be of 0.5 factor, Live load less than 3 shall be of 0.25 hectare. Why this 0.5 and 0.25? You have to read 1893 IS 1893 for the same. It gives that for seismic mass calculation you can use 1/4 of live load if the live load is equal to or less than 3. If the live load is greater than 3, you have to give 50% of that to seismic mass. Why this reduction in the live load? Because live load is not a permanent load. In the case of earthquake, it gets reduced because the people runs away. So you can reduce these loads, and the load shall come to y direction, and you will be adding these loads. The loads has been created, the seismic definition has been completed. Now you have to create the actual primary load cases and combinations. So select the load case details, press add, and create dead load of the extent DL. Create live load by saying LL. Oops, we have made a mistake. The seismic loads needs to be at the first level, then all the other loads. So we are deleting these loads. We are creating the seismic load first. Select seismic type, add EQX as the primary load, EQZ as the primary load, then DL and then LL. So DL, the type shall be dead, LL, the type shall be live, add. The load case has been created. In seismic X, you have to add seismic definition, seismic loads. In X direction, factor shall be 1, you will be adding it to 1, 1893 load X 1. In EQZ, the same thing, seismic loads, direction Z and add. Okay. In the date, select Jo. What we are doing, we are pressing on the case, we are pressing add, it will be showing us the items. So in this case, as we have defined all the loads in the reference loads, we are selecting repeat loads, and in that reference loads, all the dead loads that we have created, we are adding to the extent of 1 in dead load. As you can see, all the dead load has been counted in load case dead load. The same way we have to add the live load. Press add, go to repeat load, reference load, select all the live loads, factor shall be 1 and add and close. The load case has been created. Now we have to create the load combinations. For load combinations, limit load combinations, you have to go to IS 456 as well as 875 part 3 as well as 1893. So we can directly define the load combinations from here. Define combinations. You can add 1.5 DL plus LL, 1. plus 1.5 LL. It will be normal addition. The dead and live shall be there. The factor shall be 1.5, 1.5. This way you can add. You can start the load case number from 101, or you can add auto load combination. Let us add auto load combination in over this model. Select Indian code, general structure, and generate the load. As you can see, the loads has been created. Limit load cases has been created. Okay, press add. The load has been generated. The load case number will be selected to the last load case that you have created. As you can see, the load case is being marked as L, the combination is marked as C. So 5 to 19 are load combinations. Now we are creating load envelopes. Our load envelope shall be of this only, and it will be of strength. We are adding it. As you can see, the load envelope has been defined. Strength kind of load envelope has been defined. I am saving the structure. The load case, combinations, properties, load, support, specification has been assigned to the structure. Now we shall add the analysis command. Go to analysis, now print add. As you can see, the perform analysis has been created. We have to give the design parameters to design the beams and columns. Let's just save it. Go to concrete, in code select 456 and define the parameters. Brace shall be default 0. Clear cover for the column shall be 40 mm and for beam shall be 30 mm. Ends 1. For FC it will be 25,000. For steel it shall be 500,000. We are selecting 25 MPa concrete. Maximum shall be 20 mm. Minimum max secondary shall be 12. Method 1 for columns. Minimum man shall be 12 mm. Minimum secondary 8 mm. Ratio for column, I am just putting ratio for column to 2.5%. I don't want to congest the steel in column, so for beam it shall be 1.75. For my case, the codal provision are for beam it is 2%, or we can somewhere go beyond 2% also, but it will be more congested still in beam. And for column it is 4 to 6%. And I am giving torsion to the slabs because there is a slab and the compatible torsion will create it, and I am adding the commands of beams and columns. Just repeat the video and see the parameters that I have added because I am going too fast this time. I am selecting the columns to assign the same parameters to column. For column it will be cover, ends 1, concrete grade, assign. I am pressing assign to view for all because I have selected the columns. I am assigning the columns parameters also. Method 1 and pressing 2 times enter to select yes. For column it will be 2.5 and column. Now the selected are columns. I will be going to select by inverse beam selection. I will be giving the parameters to beams 2. Which one will come to the application to beams? I'll be selecting it and I'll be adding assign to view. Method 1 will not be applicable to beams. To know in deep about each one parameter, torsion 1 shall be to the slabs only. I am creating first view, I am selecting the slabs and adding the same assign to view. To know about each and every parameter, just go to help and read out the parameters, definition and everything. This way, the whole structure with loadings, specifications, parameters has been completed. All we have to do is analyze the structure now. Once the analysis has been completed, you can go to something called the post-processing. I don't know why the model has not been completed. Let me see it. When we are analyzing the structure, it is not analyzing the loads. Why? Let us say the error. Case being factored does not exist. Let us go to the input file to understand what happened. Let's go. We have given it is the biodata of the structure that we have created. We can see it is the heart or the DNA of the structure. It shows everything that we have inputted. We have inputted the job definitions, we have inputted the nodes, we have created the beams, we have created the groups, we have added the materials, we have given the properties, we have given the supports, we have released the structure, we have given the seismic definition and the load cases being taken for that, and then we have given the reference loads. But as you can see, the reference is being given before the load has been assigned defined. That cannot be possible. So we have to select the definition of a load, reference load, and cut paste the same to above the seismic definition, so that when it refers it comes from the above lines and not the below lines. Then we have created the load cases, then combinations. You can remove this and add the simple naming so that you can understand. It's 1.5 DL plus LL. This is 1.2 DL plus LL. Then it will be 1.2 DL plus 1.2 LL plus 1.2 EQX. Now copy this, paste it here, and EQZ. Same way, paste it here again, and it's a minus sign. Then press here, it's minus EQZ. Okay, this is 1.5 DL only. This is 1.5 DL plus 1.5 EQX. Then copy it, paste it to the next one, make it Z, paste it again, make minus. It's too easy and fast to renaming the same, but you should be doing it to understand it way much easier. Then copy paste it again and make it 0.9. Okay, then copy it, paste it, make it Z, paste it again, make minus, paste again. Let us select this, copy it and paste it, and just do the minus one. Then we had given the envelope definition, then we have created the parameters, but before the parameters you should be giving the load list. Load list is the parameter which instruct the concrete design that this load combination needs to be used for design. The syntax is load list 5 to 19. That means 5 to 19 combinations shall be used for the design of structure. Just close it and press analyze, and as you can see the analysis has been completed. There is one warning. Let us see what the warning says. It says if this is UBC IBC falana dhikna hoga. Let us remove that warning also. Just go to input file. From where we are going to input file? Here, STAAD editor. As you can see in file menu, you can get this editor, I guess. When you know the shortcut, why are you finding the options? You should be STAAD editor. We have to go to view, we have to input command file. We can see the command file. We are not seeing the editor. Where it shall be? I guess it should have been in the edit window. Okay, so we have to remove that UBC IBC. So in load case of earthquake, below the load case definition that you have given for earthquake, just add perform analysis and change. Copy the same, paste the same to Z also, and close the window and run the structure. As you can see, there is no warning and the structure has been completed. Let us see the result. Double click on the beam so that the query window will show. In concrete design, the reinforcement shall be seen. As you can see, the structural columns are of 230 by 450. So we can give the reinforcement in two direction only. So we should have been giving the rface command that we have not given right now. Let us give the rface command. Design concrete 456. Let me first show you what it will do. Just remember the reinforcement of this column. The reinforcement required is 626 mm square. Okay, let us see what happens if we give rface command. It will be given after ratio. There are two rfaces, rface 3 and rface 2. rface 4 is by default. It gives the reinforcement on four sides. If you can if you can connect this to SP16, it gives us the table sources charts for 2 side reinforcement, 4 side reinforcement. This does the same. RFS, we are just adding RFS 3 and RFS 2. Remember, I have clicked on after current because I have selected the ratio and I want that RFS 2 and 3 after that. Which RFS will be assigned to which one? Just write RFS tiny topic TINY, sorry, TINY TOPIC, and the RFS window will open, and we can directly get that vertical columns shall be of RFS 2, horizontal shall be of RFS 3. So just press Ctrl 1 so that you can see how the columns are aligned. Vertical shall be RFS 2, 1 and 2, RFS 2. The rest shall be RFS 3. Right? We are not giving RFS to this bigger columns because we can give 4 side reinforcement to them. I am pressing Ctrl 0. I am just analyzing it again. Now we have given the RFS 2 to the vertical columns and 3 to the horizontal columns. Let us analyze the structure again and press double click it and see the reinforcement. The same reinforcement is being coming, show no issue, but you should be giving the RFS command to the structural columns in which we are giving the reinforcement in 2 sides only. This way the structure can be modeled, analyzed and designed. You can select the beams to see the beam results. You can go to the output file to see the results of beams and columns and get the reactions, displacements and etc. everything. Go to post processing. For the limit cases you can see the displacements and everything else that you want to see. Thank you for watching this whole video to the last. Do like, share and subscribe the same, and keep pushing me hard to make some more videos for you. Thank you.